So the next part is how to write these equations, well, given the information here. So we have the center, we have the point. So we say, all right, can you write the equation? So I'm going to write down the form again. So we have x minus h squared plus y minus k squared equals to r squared. So if we are given a center, that means we have the h, we have the k. We have these two numbers already. Life is good. Okay, life is good. But now we're missing something. We're missing the r. So we will need to ask the question, how do we get the r, or how do we get the r squared? Well, if you have a center and we've got a point, what can we do? We can find the distance. Okay. Now, if you are using that approach, I would strongly suggest you to make a quick graph. Okay, like a 3, -1, just a rough sketch. Okay, so that you are not being fooled by yourself, because sometimes if you go too fast, you might miss something in transition. So that's the actual distance. So if you want to say, oh, I want to find out the distance, sure. Okay, the change of y square, which is 5 square, plus change of y, or change of x is 5, change of y is 3, is equal to r square. Okay, so so you can just do 25 plus 9 is equal to r square. And a lot of people is going to get the addition wrong right here. You know what they would put as the answer for r square in this case? It was very tempting to write down. What's the correct answer first? 34. What's a very tempting answer that people will write here? 36. You know why people will write down 36? Yeah, like 9 and 25. Guess what's next? 30 something, 36. But no, it's not 36, it's 34. Now here comes a very important question. Should we or should we not square root both sides? Should we or should we not do the square root? We should what? We shouldn't. Why not? Yeah, the equation asks for r squared. So if you get the r, well, you end up squaring that again. So I would say yes. Just don't square it. Don't square root it. Okay. Just keep it as 34 and put it there. And we're done. So insert the x and y values in there and make sure you do not forget about the square. Make sure you do not forget the addition between the two parentheses. Okay. It's just a distance formula, Pythagorean formula, theorem. You know how we did the vectors. Okay. Now there's another way to obtain r squared. There's another way to obtain r squared. Let me show you. The other way to obtain r squared is this, and that is if now we should have this part ready. Okay, because we're given a center. So to obtain r squared, we would say, wait, they give you a point. We should be gracious about this wonderful information because you can simply insert the x and y values into the equation. And you only have r squared on the right-hand side, and you just go ahead and solve for it. And you say, well, what's r squared? Oh, it's -5 squared, which is 25. 3 squared, 9. So you got the same number, 34. So that is the other way to find out the r squared, which is by simply substituting the points into the equation. Okay, so make sure you are aware of these two ways of doing the math. Right, the next one, it's kind of similar. You're given a diameter, the endpoints of the diameter, but you are not given the center, you are not given the radius directly. Can we find out the center? How? Okay, that will be useful if they have the same x value or the same y value. But they have the different x value and they have a different y value. So if you just say adding get the distance divided by 2 and then you kind of backtrack and count the squares, that will be a little bit more challenging to do here. But now I would say something valuable with that step is that you can find out the radius. We can find out the radius. If you can find the length of the diameter and divide by 2, you get the radius. But there's an easier way to find out the center. There's an easier way to find out the center, since we are given the endpoints of the diameter and what's the relationship of the center in relationship to the endpoints. Yeah, just add them up and divide by 2 because it's the midpoint, right? The center is the midpoint of those two endpoints. Now, and here comes a question. There are people who forgot how to find midpoints. So I would say this. Okay? In a very hypothetical situation, and a very easy situation too, if I have 2 points right here on the x-axis, 2 and 6, what's the midpoint between these 2 points? 4, right? And I say, oh yeah, it's 4, and you can see it's 4, but how can we do it mathematically? 2 plus 6 divided by 2, which is how you do averages, right? You have done your averages all the time. You average your test scores, right? Quiz grades. So it's just finding averages. So the center in this case would be -2 and -5. That's the center. So to find out the radius, you may do the previous method, or you can do the substitution. Do you want to do the distance formula, or do you do the substitution? Which one do you prefer? Substitution? I think I like substitution better. So you have x plus 2, square, plus y plus 5 square equals to r square. Okay. And then now we will substitute the values. So I'm just going to pick this point. So 1 plus 2, -2 plus 5, it's equal to r square. So we got 9 plus 9 equals to r square. So r square is simply 18. So the actual equation is x plus 2 square plus y plus 5 square equals to 18. Okay, so if you are given the endpoints of a diameter, that the midpoint is the center. Then you get 0, 0. Yeah. And also, the other reason why you would not substitute the center to the x and y, center is not part of the line. You can only substitute if the point is on the line. Okay?